Welcome to this talk. I'm very glad to see that so many people made it to a security talk Friday after the party. My name is Geir Olsen. I am a program manager on the Windows Phone security team. I've spent the last 6 years there. So I've been part of this effort since Windows Phone 7 and have been responsible for app isolation, code integrity, and now in this release, Windows Phone 8.1, I also worked on Microsoft Account. I like to, the agenda slide, I usually get lost on the agenda slide, and then I talk through all the points on the agenda slide. So when I get to the other ones, I just have to kind of fast forward. So this time, I'm just going to show it to you briefly. This is roughly what we're going to be talking about. I'm going to start by talking about some of the security goals for Windows Phone. And we've been very serious about the security goals that we established for Windows Phone 7, and we've stuck with them ever since. And we measure everything we do against those goals. And whenever there is a big topic that comes up related to security or some feature that has risk associated with user privacy, we always go back to the goals and do like a bar check. And the first goal that we established was end-user safety and privacy. So for us, number one goal is end-user safety and privacy. End users should feel safe using a Windows Phone. They should feel safe giving the phone their information. That information, how it's handled on the phone and in the supporting cloud services. Users should feel safe downloading apps from the store. They might not be happy that they paid 99 cents for a bad app, but they should feel safe that the app will not wreck their phone experience. If they don't like the app, they should be able to uninstall the app, and there should be no lasting damage on the device. For privacy, we take privacy very seriously. Whenever there is an issue with user privacy, we believe that there should be transparency and user choice. So as best as we can, we try to avoid too much prompting. We find that prompting doesn't work in general. We've been prompting for 2 decades at Microsoft, and we have tons of user data showing that prompting, asking, are you sure you're going to do this, plainly does not work. Authentic user gestures is better. Sometimes we have to prompt because legally the law says we have to. But we like to make it clear to the user what's happening and in the context that it's happens, and then give users the choice to continue or opt out. The second goal that we have for Windows Phone security is developer trust. We want developers to trust the platform. We want developers to trust that they're going to get an honest pay for honest work, meaning we try to keep piracy as low as possible. And we have measures in place to prevent widespread piracy. We want developers to trust that their intellectual property is safe on the phone, that it's safe from the beginning when you ingest the app to the store, when the app is in the store, is being downloaded to the phone, and the app is safe on the phone. The sandboxing that we built was not only built to prevent malicious activity from the app sandbox and out, it was also built to protect the app from other malicious activity on the phone, so from outside and in. Now, when we look at the goals for 8.1, we basically just, in that context, looking at the goals for 8.1, for end-user safety and privacy, we really tried hard to build features that minimize the amount of times users have to re-enter their credentials. We sold this set of features under the slogan, I hate passwords. And I think 2013 and even 2012, people just came to realize how bad the password solution really is and how much people hate passwords. I have friends that are like non-techies. They go to websites, and every single time they go to a certain website, they have to go through the I forgot my password flow. And so we made an effort through various features, as I will show you, to reduce the amount of time they have to re-enter them. And we need your help. Like I assume most people here are developers. We need your help to extend that to applications. We've been lacking since Windows Phone 7 in good APIs for crypto and certificates. We've heard you over and over again. Finally, in 8.1, we are on par with what's available for Windows. And the last bullet point here is kind of mysterious, and you'll understand when we get a bit further. We wanted to move the dial forward on enabling use of phone as an authentication device. So yes. Microsoft Account, let's start there. So we've had Microsoft Account support on the phones for a long time, but we've been using a version of the Microsoft Account protocol and stack that is many, many years old. It was basically forked many years ago for Windows Phone or Windows Mobile, and we carried that forward. And that means that the protocol was old. It had bugs that didn't exist on Microsoft Account on Windows. So in Windows Phone 8.1, our goal was to throw out the old and converge with Windows on their stack. This has benefits from the Microsoft Account team obviously was very much behind this because this means that they have one less legacy protocol that they have to support. So what we did was we literally threw out the old stack and put the new one in and took what we had on Windows 8 and Windows 8.1, and then we trimmed away some additional legacy. So on Windows Phone 8.1, we have the latest Microsoft Account stack with the WinRT APIs. And that's the only APIs we provide, even for inbox experiences. All of the user experiences that come with Microsoft Account, like the sign-in pages and all the interrupt pages. Interrupt pages are pages that we will show to the user when there's something wrong with the user's account. It could be that there's too many password attempts, the account has been compromised, there's some kind of intrusion detection thing that's kicked in from the MSA Cloud that says, hey, this user signed in from China half an hour ago, now they're signing in from California. So there will be an interrupt showing, and all of that UX is now hosted in the cloud, which has huge benefits for us. It means that we can now evolve the security story around the Microsoft Account without relying on a client update. And everyone here knows how hard time we have in getting the client updates out from the mobile operators. So this is very big. Now we can literally improve the security of Microsoft Account almost overnight by just pushing out a cloud change. The Microsoft Account is the primary identity provider for Windows Phone. What that means is it is the identity for the Windows Phone. On Windows 8, users were able for the first time to log into Windows using their Microsoft account. And when they did, underneath the covers, the Microsoft account was connected to the local user account. If you're familiar with Windows security, I assume some of you are, there's locals accounts and there are domain accounts. So when users log into their Windows PC with their MSA, the MSA is connected to the user account, which means it's the only MSA that the OS will see. And we do similar things on Windows Phone 8.1. We connect the primary MSA to the user account that you didn't know existed, but there's actually an account that we create. It's a hidden account. There's no username and password that you'll ever see, but we do create it, and they're connected so that all use of the MSA API post that point will be against that MSA. The majority of users on Windows phones sign in with MSA. We have all of the major and minor experiences that we offer on the phone that has any kind of cloud backing use MSA. And when I say use MSA, I mean use MSA as an authorization ticket provider. So in addition to providing like identity services, Microsoft Account provides token or ticket support for a number of Microsoft Cloud services. Things like music or Xbox Live or backup, sync, roaming, all of those features rely on a ticket that they get from MSA. And they ask for the ticket from MSA, MSA will issue it, and then they use that ticket and pass it up to their own service as an authorization token. To get those tickets, you need to use the new API, which includes a single sign-on. Because we link the primary MSA to the device, once the user has signed in once, there is no need for the user to sign in again. So every service or app that requests a ticket beyond the user sign-in point will not trigger a new sign-in. The namespace with the API is windows.security.authentication.onlineid. And we'll take a look once we've gone through some of these benefits. So data roaming. I don't know if you've bought a Windows device lately, but I certainly appreciate the feature that when I sign in with my MSA, a lot of my preferences that I've entered on other devices where I've signed in with the same MSA will automatically roam down to my recent file list on Microsoft Word. With Windows Phone 8.1, we have converged with Windows and app data roaming, which means if you have an app that runs on Windows and you create the same app on Windows Phone, and the same in this context means the two apps have the same identity. I'll show you what that means later. If the two apps have the same identity, and you follow simple conventions in putting app data or user state into certain roaming folders, the platform will do the rest. The platform will roam the data from one device to the next. If all of us do this, the benefits are substantial for the end user. Now, working on the Windows Phone team, I have a lot of devices, and we test continuously. We call it self-hosting. And I flash new images on my devices every week, sometimes multiple times a week, sometimes multiple times a day. So I have entered my credentials enough, like over and over again. We have to set up the phone. With Windows Phone 8.1 and our backup, restore, sync, and roaming features that all rely on MSA, it is so much easier now. I get a device, I put a new image on there, I enter my MSA, and now ton of stuff just works, including things like credential roaming. I've already talked about how us converging with Windows allowed us to put the user experience in the cloud and evolving then security independently of the platform updates. If you choose to use MSA as your primary, as your identity provider, you should also know that because every single experience on the phone using it means that the code paths are heavily exercised, which gives you reliability. So there are three options for using MSA for a developer. This is Microsoft. 3 is better than 1. So joking aside, Online ID is the preferred one. Online ID is the namespace I just talked about. That's the one that's going to get you to the connected account. It's very simple to use. I'm going to show you some codes very soon. The Web Authentication Broker, which I'll get back to later, is another option, primarily only because MSA supports OAuth, and Web Authentication Broker is a generic OAuth mechanism. Live ID is the third. Live ID SDK has been the only way on Windows Phone 8 devices to use MSA. It continues to live on in Windows Phone 8.1, and the benefits over just using Online ID is that that SDK contains some nice abstractions for working with OneDrive. So if your app relies on working with OneDrive, consider using Live SDK. So what I thought I was going to do now is take you through the out-of-box experience. There you go. All right, so the device that I have here is just an engineering device. I just put the latest build on it, and I'm going through Ubi. We call it Ubi, out-of-box experience. And at some point, I'm going to get to this page. This is still a local page. This is where we try to sell the user on using MSA. I don't have a SIM in this, so there's two paths forward. Don't have a SIM in this device, but when I have Wi-Fi here, so we'll do it through Wi-Fi. And what we'll try to do in Ubi already is we're going to take the user through what we call proof up and two-step verification. So proof up will first check that the user has enough proof on their account, security proofs. And if they don't, there will be an interrupt that you'll see prior to this or after the sign-in page that will ask the user for their birth date and other information. These are pages. This page right here, even though it looks like a local page, is actually hosted in the cloud. So sorry for the slow typing here. Sorry, it's a test account. So this will okay. So what it did now, it signed me in, and now we're going to try to sell the user on doing backups. And the next step should have been TFA. Has been all day and all day yesterday, but it's not now, so you'll see that later. Okay. So anything I use now, so the store is one of those apps that are using MSA. I like sports. Let me see. So this will start going, and because we're already signed in, only thing that the store had to do was to ask for a ticket, and the ticket was automatically issued. There was no interrupts. There was nothing wrong with my account, and the ticket granting ticket was already issued. I'm going to switch to Visual Studio, and I will show you what that code looks like. And the code I'm going to show you here is more or less exactly the same that's in Ubi. Can you see this in the back? Yes? All right, so the first thing I do is I include the namespace, Windows Security Authentication Online ID, in the using section. And then here it is, like it's 3 lines of code. Basically, I create an instance of this class, Online Authenticator. This is the class that has all the logic that will go and actually get the ticket. I create an instance of this class that prepares a ticket request and asks for, we call these scopes. So basically, this is a set of information that's defined as wl.basic. And if you go online, I have this in the resources section, there is a documentation online that shows you what scopes that you can ask for. There's a number of scopes that's related to contacts, to calendar, to OneDrive. And you can ask for multiple scopes at the same time by just have a comma-separated list, and this is all text. And the second piece to this is just, this is basically called a policy, and is always going to be delegation. This is the policy that we use for apps when they request tickets. And then there's this await call where the online authenticator goes online and sends the ticket request. This, and if successful, this will return a user identity object, and this particular sample app that I have will just dump the saved customer ID from that object into a list view. But basically, in Ubi, those are the 3 lines that we have. There's no controls that shows the UI. There's nothing, no knowledge about the UI. It's basically just go get ticket. And then all the UI that you saw for sign in and everything else is then automatically triggered by the stack itself. That clear? So I'll run this. And eventually, the app will start. And basically, this is going to take me through, and maybe you'll see the TFA stuff here. It's going to take me through this because the emulator kind of clears out every time it starts. So excuse me for taking you through this again, but hopefully you'll see the TFA now. Same password. Okay, so this is what we should have seen before. I'm not sure. Maybe it's because I've been testing it all morning. To verify the last 4 digits of my phone number. There you go. All right, so you see the output showing. So now the ticket request is complete. So basically those 3 lines of code produced all of that. The stack noticed that the user hadn't signed in, so it popped up the sign-in dialog. And the cloud said, hey, this user hasn't gone through TSV, or two-step verification, or two-factor authentication yet, so we're going to take the user through that. We're pretty aggressive about that because some of the services that we have rely on it, like credential roaming. And there you go. Now I got the ticket. If I do it again, of course, now that the ticket or the interrupts are all been handled, I'm going to get the ticket returned, and the user identity object is much faster. There's caching. There's all kinds of stuff going on. So that's online ID. I'm not going to show you WAB for MSA because I'm going to show it a little bit later. But I'm going to do the live SDK, or how am I doing on time? So the APIs here look slightly differently, but they use online ID underneath. And if possible, they're even simpler. So a single line of code after the initialization above. And then the rest of the code here is just going and pulling more data from the basic scope. So it's going to take me through that whole thing again because the user hasn't signed in. And at the end of the day, it's going to show you different information on the back end. I think I'm going to skip that now because I'm going to move on to the next demo. Trust me, it's the same thing because it's using online ID. And this programming model can then be used to download and upload files to OneDrive really simply. Second topic for today is Web Authentication Broker. So this is about OAuth, and most of you probably heard that term before. OAuth was created to solve the general problem of allowing users to allow apps access their cloud resources on their behalf. There's two implementations or two versions of the spec. We're at OAuth 2.0 now. And the flow goes as follows. There's an online service. There's an app. It starts with an app making an authorization request to the online service. Included in the request is an app ID that the app developer received from the online service at some point, plus an app secret that the app developer also got from the online service. The service is going to say, hey, who is this? Who are we authorizing for? It's going to make the user sign in. This is the first step of OAuth. This is basically the authentication step. The user is going to provide their credentials, and there is kind of this implicit promise in OAuth that the user should only ever have to provide their credentials into pages, a set of pages that's owned by the online service. After the authentication, there's a second step that comes the consent. So the service will say, based on the scopes that were requested in the ticket request, the online service will do a prompt and say, can app A access all of your information, or some of it? And the user then makes a decision. If the decision is yes, the service goes on to issue the token, and the app can do the data access. So some of the issues that we saw with this is that every developer that did this kind of did wing their own solution, and which meant that every time, if you had 3 apps that wanted to access your Twitter information, you had to sign in 3 times. Credential isolation is poor because typically the apps would render the service web pages in a web control that they hosted in their own process. And because every developer did their own thing, the user experience ended up being inconsistent in some cases. And something that's really important for phone is really not predictable in low memory situations. I'll get back to the low memory piece. That's something we worked on a lot. So Web Authentication Broker, or WAB as we call it, was invented. It does provide single sign-on. It has a simple API. It does provide credential isolation. And it does that through the broker infrastructure. So a little short lesson on WinRT and brokers. So there's a trust model in WinRT. It has 3 levels to it. It's basic, partially trusted, and full trust. And depending on how, and the trust levels are typically markup on the classes themselves. And depending on the level, it basically dictates where the object is going to be activated. So since WinRT is COM, fundamentally, and developer does an activate or a new on a class, the Windows runtime is going to look at the class and say, what's the trust level on this class? If it is basic, it's only ever going to be activated in proc. If the trust level is partial, then the runtime and the caller is running in an app container, then the COM runtime will activate that class out of app container in what's called a full trust environment. I hate that term personally, but that's what it's called. And And since it is, it's basically out of process and out of app container. So you get the isolation. So the sign-in page, whatever the broker is showing, is going to be running in a security context that's different from the app. So the API that we ended up with is different than what's on Windows. And we had to do this because of low memory. So we are very aggressively pursuing low memory devices and working great on providing great experiences on low memory devices. That means 512 meg. And what we experienced was basically when you launch a process, an app, and that app brings up UI, and the UI isn't owned by the app, it means it launches in some other process. Now that other process is in the foreground, and the app goes on the backstack. And on the phone, on a device that has very low memory, that typically means that the app almost immediately gets suspended. And if the app gets suspended on the phone, that means it's out of memory. It's basically unloaded from memory, which means when the user is done signing in and doing all the things, providing codes, and that's all done, now the app is rehydrated and comes back saying, what? What just happened? And so what we ended up doing was introducing this new pattern and corresponding programming model. There was a talk about this yesterday. If you want to look it up, I think it was called, the number was 2-520. And the video should be online right now. But basically what it is, and I'll show you, it's called a continuation pattern. And we'll switch to Visual Studio again. And what that does is, if you look at this WAB code, which is very simple, we're setting up the start URI with some additional metadata like the app secret and the app identity. And we set up the end URI, and then we call this method on Web Authentication Broker that has an API that has a name that ends with and continue. So basically what this does is this will be called, and the user will see a UI, and then it will return. And what happens next is that the onActivated method on the app is going to be called. And in my onActivated method here, there's a code that deals with continuation. And so basically, when the app was suspended, some state was saved, including the navigation state. And now when the app is activated again, we discover that the app was in a continuation sequence, and the page that it's hosting, this code of mine, has an interface called iWeb Authentication Continuable that ends up being invoked, and then there's a method in here called continue web authentication. That's going to complete the operation, actually go and get the token and do additional operations on it. So this is guaranteed to work on low memory devices, and we'll demonstrate. So this is all WAB magic now, bringing up the broker, showing you the app in the title bar up here. It's showing an authentic Twitter page. Remember not to do tab. Let me see. And there you go. So now you see this is the end There's the end URI, and this is information that was obtained from Twitter. This is what my test user is called on Twitter. So this now went through all the flows that I showed you in code and called back on onActivate, and then called back and completed the ticket response, and then went back to Twitter and asked for the user information. Is that cool? Yeah. So let me see. All right, so when it comes to credentials, I don't have any demos in this section because it's not boring. It's just that the demos get a little boring when you show crypto stuff. But it's cool the fact that we now are on par with Windows when it comes to storing credentials. We've had lots of questions like, how do I store a secret? Well, now you have this windows.security.credentials namespace and classes with the password vault class that you can use to store credentials. And the benefit is that this vault actually roams if the user has TFA'd on the device and the user is opted in. The vault will roam between devices where the user has signed in with the same account. You have secure storage, plus you have credential isolations, because every app container has their own password vault. So very simple code that I've included right here on the PowerPoint, and it basically creates an instance of the password vault class, and then you can save a set of credentials using a tag. And then later on, when you need it, you can retrieve the credentials with that same tag. For crypto and certs, we now have convergence on WinRT. All these namespaces that you see here are supported on phone. All the modern crypto algorithms, client certificate authentication. So client certificates, mutual authentication using a client certificate was a pain in the neck or not even possible on previous versions of the OS. It's completely possible now using these new APIs. And the data protection APIs include the possibility for digital signatures, so data verification and secrets, encrypting secrets in memory, et cetera. So this is kind of the feature that we didn't think we were going to do. So when we started Windows Phone 8.1, we didn't know what we're going to do, that we were going to end up doing Virtual Smart Card. And every time, we really wanted to do it because we thought, this is going to move the dial a little bit forward for us. And a lot of people wanted it. For example, the enterprise team wanted it for S/MIME and secure browsing. So with the help of many teams and resources from across the company, we actually managed to pull this in. So this is part of Windows Phone 8.1. It is now possible to have a hardware-based two-factor authentication for S/MIME and secure browsing, plus all the scenarios that you guys can dream up, because all the necessary APIs are available for third-party developers. So keys are bound to the hardware. You can create a TPM container in which you can import, like in the case of S/MIME, or you can enroll a set of keys that are then will only be released when the right PIN is provided. So the user has to provide a PIN, and I'll show you, I have a demo of that too. And the Virtual Smart Card functionality is built on top of the TPM. Every Windows phone, you kind of knew this already, right? Every Windows phone has a TPM in it, a TPM 2.0 compatible TPM, which is implemented in firmware on the TrustZone secure hardware that's available on all ARM, at least on our ARM SoC. Here's a simple diagram that shows, for this to work, the virtual smart cards are typically provisioned using an enrollment application. So your business could write one, or a business could write an enrollment application that uses the WinRT virtual smart card provisioning APIs, which in turn is also implemented as a broker at some point so you can do the PIN prompting. It talks through a TPM KSP, which is now also available for developers to use freely, which in then turn creates the container and creates the keys or imports the keys. An app can then, like the browser, and we've implemented this in 2 places in the platform, an email app and a browser, is then using the CNG APIs to work with the smart card KSP. So let's see if I can. Okay, I don't want you to see my password. Let me see. Because this is my phone. All right, so for self-hosting, we created this simple app. And because I didn't know that it was going to be working, I did some of this morning, pre-provisioned some stuff. Let me see. So this is this little green box that you saw in my diagram. And I've already created a virtual smart card in here. So now I can go out to the browser. And I'll go to a website that we've set up. And now it's going to ask me for my PIN. And there's the page. So that's a virtual smart card protected mutual TLS, mutual authentication with PIN protection. Isn't that cool? So this is my last topic. Apps on SD. There's no APIs here, but I just wanted to mention this to you. This kind of goes to the goal, a second goal of developer trust. And that we want you to know that we want your IP to be protected on the device. So on low memory devices, low cost devices, it will typically ship with very little storage, right? So it's been, in Windows Phone 8.1, we decided as a great feature for low-cost devices would be if we could allow app install on the SD card. And not like the competition is doing it, where some of the app is on internal storage and some of the app is on external storage. And if you buy a 64 gig card, you can still run out of app storage long before the SD card is full. So what we do, Windows Phone 8.1, we allow you to put the whole app on the SD card. And because we were afraid what was going to be exposed, because it's so easy to take the SD card out of the phone and pop it into a PC, for example, we did a couple of things. We have encryption of all the files, app files that are on the SD card. And we have, the encryption is similar encryption to the data protection encryption we do on the device itself, ergo like BitLocker style. And we use, it's folder and file based, and we do one key for program folders for an app and one key for data folders. So every app has different keys. And within an app, we have 2 keys, one for program, one for data folder. I won't get into exactly why we did that, but there were some threats that we envisioned could happen, so we took the extra step and gave you the extra protection. In addition to the encryption that we have, we also have access control. And considering this is a FAT file system, that's pretty cool, right? We did access control for FAT, which is kind of done through an indirection. If you're an app developer that still don't want your app to be on on an SD card, there is a way for you to opt out. And if you open your AppX manifest, you'll see that there is a checkbox right here. Probably can't be read from the back, but it says SD cards : prevent installation to SD card. If you check this, there's a metadata that's included in your manifest, and your app will always install to the internal storage card. It's an opt-in, though. It's not an opt-out. And I think that takes me to the end of my talk. So do you have, we do Q&A? Want to do questions?
With all of your connectivity with a common ID, your Microsoft account, how do you protect the information in the account from external sources? So you've got your phone, you've got your Surface, you've got your desktop devices, you've got your email list, you've got your telephone calls, all of these pieces of information now linked with a common identifier, your ID. How do you protect that from intruding eyes and ears?
So you're thinking NSA?
I am not thinking of NSA.
Right.
I'm more concerned about the advertisements and spam that we get.
So it becomes more important than ever that people use the proper security, like on the MSA account itself. Like, for example, I have enabled, I thought it used to be annoying, but I have enabled it, and I actually like it, the two-factor authentication. You can go to MSA, go to accounts.live.com, you can go there and enable two-factor authentication for login. That means every time someone tries to log in, you now get a code that you have to supply.
But now all this data is stored in the cloud. You're storing this data someplace. I can get at it through these mechanisms.
Right.
How do I prevent anybody else from getting at it?
Well, for
How do I
anyone else,
prevent Microsoft from leveraging that information for non-security purposes?
well, that's a big topic.
Yes.
So it's a big topic, but some of this is done through terms of service and things that you sign on to. So some of the things that we do as a company with your information is disclosed. It might be in a very fine print, but it is disclosed. The protection from others, that really comes down to how well you have protected yourself with the password and the two-factor authentication, all of that. And the care that you take when you allow apps access to your information. Like what we said about prompting, it's remarkable how fast people can dismiss a dialog box. Right? If you want to see response times lowered like in milliseconds, just put up one of those dialogues that says, "Are you sure?" And it will be gone immediately. So if people take care of, is this Fart app really need access to all my data? It's like, no. So if it's unreasonable, if the app seems greedy, just say no, don't take the app.
Hi, Justin Angel. So two questions, actually. First one is about the web authentication broker. So it seems like the primary benefits of it is I get the cool OS Chrome around Twitter authentication or Facebook or whatever, and it asks me to remember my password. I was wondering if you're considering a step further, like other operating systems have, which is just storing my Twitter, Dropbox, Facebook credentials on the device and then authorizing me somehow through that. So not even asking me to get permissions, authenticate at all when I need to go on Twitter and Facebook. Just store that on the device.
Store the credential on the device?
Yes, some other operating systems, which, let's not mention which ones, have that as a feature. Some sort of a credential store specifically for that stuff. And then authorize me through the OS to get access to Twitter, Dropbox, Facebook, whatnot.
So the way that I can think that could be done, so basically we would never give up anyone's credentials through any kind of capability. That's just not safe, in my opinion. But allowing some brokered access through a ticket granting ticket, that is obtained, if you have the credentials, you can. Typically what happens if I go to MSA and I sign in, MSA will issue this TGT, we call it, ticket granting ticket. You have to have that before you can get other tickets. And that is always going to be on the device. It's an opaque kind of thing. It's there, but MSA knows what it is. So maybe there's some brokered access that could be granted to that. Yeah, we'll have to think about that.
Awesome to know you're thinking about it. And my second question, and it's more of a general security question, it doesn't have to do with a lot of stuff you showed, just wondering if something happened about this. So Samsung shipped their phones, which were nice, but they also had some sort of a hack there that allowed people to get elevated permissions.
Right.
And then look at my app files, for example. As an IP holder shipping apps on the platform, that concerns me.
Yeah.
Has that been addressed in Windows Phone 8.1?
Yes. Well, so since we shipped Windows Phone 7, our biggest weakness has been our partners, and from a security perspective, because and kind of a pillar of the security model is OEM trust. If that falls down, what we've seen over the years is that, because we have a pretty locked down OS. Everyone says that. I don't know if you read the Chinese hacker transcripts that said about the Chinese New Year, I gave up, right? He was trying to hack in. And because we do, sometimes this causes the OEMs problem because they still have to ship devices. So what they do, because we haven't done a good enough job opening things up for them to the degree that they want, they create these generic bypass mechanism. And what they've done over the years is like there's a driver typically that says, hey, pass me in a reg key and a value and I'll write it for you, right? Those kind of things. And we've been pretty aggressive and working with our partners in getting those closed. And I've been on several threads and conversations with this particular OEM about their Ativ devices, about this particular weakness to get that addressed. And as far as I know, those have all been addressed in newer versions of the software. There could still be Ativ devices out there that have older software where this is still possible, but I know it's been addressed on the newer versions.
Excellent. And follow-up question to that, aren't you concerned about the 9 new OEMs that now have the ability to fuck this up as well? Because previously there were only 4, now it's going to be 4 plus 9.
Yeah.
Does that keep you up at night?
Yes. So we have the WRD program. The way I've talked about this internally, and I'll share with you, is that anyone with $99 and a credit card can now be an OEM. And now couple that with what I said earlier, that one of the pillars of the security model is OEM trust. And so we've taken some steps to mitigate that. And we can talk about it online, specifically what we've done. But what we've tried to do is we've tried to prevent we call it cross-pollination. We try to prevent one OEM from screwing up other OEM's devices. So that means that we cannot prevent one OEM from creating bad devices, but we can prevent that OEM, a malicious OEM, or some entity that passed off as being an OEM from writing rootkits that can be installed generally on all devices.
And that's awesome, but as an IP owner, as long as my IP is compromised on one device and from any OEM, like my Zap's available for people to read, my music files are available, I'm screwed, right?
Yeah.
So that's why I'm worrying about that one OEM that doesn't do its job.
Right. Another thing we're doing is we are doing more additional screening above and beyond the $99 in the credit card. So we're doing screening and doing like follow-ups with the. So we've basically rejected a few already that have come through. So because we found out that one of them was a company that lives of selling tools to hackers or whatever. So we said no to them. But yeah, that doesn't necessarily keep me up at night, but that's definitely a big concern of a security guy like me.
Excellent. Thank you.
Yep.
Hi, so I had a few questions, and I'll go to the back of the line at some point if people get impatient with me. First, you misspelled cryptography on your slide.
What's that?
You misspelled cryptography on your slide. I assume that's not the actual.
Okay, yeah. Actually, this slide was one of the last ones I did. I'll go over this before I pass it off.
So some questions about the pushing the things out to the SD card questions. So I think you said that those are all encrypted on the SD card. So I guess the two questions I have are, first of all, and I think I heard in another presentation that they're different, they're per phone keys, so you can't transfer them between phones. So So the two questions I had, first of all, is there overhead performance-wise for me accessing my application and data on that? Or is that dominated by the speed of the SD cards, which are usually slow?
Yeah, you'd be surprised. So I was hesitant to begin with when we talked about SD card, and everyone was worried about performance. I have I have one of those Manypenny devices that has an SD card in it, and I keep all my apps on the SD card. Actually works really well. I mean, I have no issues with it. Now, as it comes to like real numbers, it turns out that some of the cheaper devices ship with not so good internal storage, so that kind of washes out. If you follow the chassis spec on the performance numbers that we recommend or that we require for SD cards, then you won't see many issues with performance, and I haven't seen many personally.
And the other question I had is...
But as an app developer
Yeah.
that care about your reputation, you should get a device with an SD card in it and then test your app on it, maybe get 2 or 3 SD cards with varying performance and then test on it.
And the other question I have is, so as a user of a phone, if I have a phone and I've got things on the SD card and then I manage to drop my phone and it shatters, but the SD card is fine, am I just as screwed for the apps on the SD card as I was for the stuff on the internal storage, or is there some way that my new phone can recover the keys from the old phone?
No, you're screwed.
I believe if it's on the same account, I attended a session for the SD card. If it's on the same account, they said it's,
No.
if I put the SD card on the phone, if I have the same Microsoft account.
Phone and the device, the ID and the device itself.
So it's same
No.
account, same phone.
The keys we're generating are random. They are there for the device, and we seal them with a TPM. They're secure and all that, but it doesn't derive from your MSA.
And if I wipe the phone, am I equally screwed?
What's
If I
that?
wipe the phone and without the SD card in it, it's the same thing?
Yeah,
The keys are also gone?
right.
And then the third question, is there a way as an app that if I want to say, put a file on the SD card that's not encrypted to let the user transfer it to a PC or something easily? Is there a way to do that? Or can I only put this in the encrypted storage?
No, all app files are encrypted. We kept the FAT. We kept
Okay.
FAT because we wanted the swappable music and media scenario to still be true.
Okay. But,
Right,
so there's
so
ways that I can write generic files to an unencrypted part of the SD card or not?
No.
Okay.
Well, Cliff is in the back of the room here. If you write a file to your public folder on the SD card, I would assume that file is not encrypted.
Okay.
Yeah, that's true. He's nodding.
So MSA rhymes with NSA. I'm just joking. That's not my question. We at Intel are looking for an enterprise solution for our phones, for our employees to use. And we have our internal internet and the VPN and everything. And we have our own, obviously, our accounts that we log on to Outlook and Lync and everything. So if I have a user phone and it's a BYOD device, like a user brings it in and we want to install the same functionality, how does the MSA interact with the account for the for the internet, for the company's network? And how does it work? Is it only one at a time, both accounts active? When I'm on my company's network. Yeah, I mean, everything, right? I mean, now they've got everything in 8.1, right? I mean, you can be on the company's network and have all of your email syncing, all of your link and everything, right?
Enterprise accounts through
Yeah.
Office 365. all
Yeah, enterprise accounts, everything. So how does MSA interact with that?
It doesn't.
Okay.
MSA is a consumer-oriented identity provider.
Okay. And I can have multiple accounts on my phone when.
You can access SharePoint. You can use your domain credentials and enter those and hit SharePoint sites and stuff.
Okay.
But there's no tie-in. There's no tie-in between your MSA and a domain account.
All right, thanks.
Right.
So the other unrelated question I had was, do you have, or are you getting a FIPS certification for the cryptography in this thing you're showing here, the Windows security cryptography? Is that planned to be?
FIPS, yeah. So we have for Windows Phone 8, and I know we're going to get it. The question is just when we're going to get it.
Okay, so
I
it
mean,
is
and
in the plan.
Windows is already working on it. They might have received the certification already. We always do it, so we
Okay.
will have it.
Okay, great,
Yeah.
thanks.
Is that it? Thank you.